Okay, so now we're going to do the same thing when x is 4. What did the distribution of y values look like when x is 4? So y is approximately normal with a mean of 2 plus 5x and a standard deviation of 1.3. Well, when x is 4, you're just replacing the x with 4 and working it out. What is the mean when x is 4? 22, and there's still a standard deviation of 1.3. So what does it look like now? Well, if you have the same picture, but now the mean has changed. So it's 22 and 23.3 and 23.3, 24.6, 25.9, and then this will be 20.7, and then 19.4 and 18.1. So I want to relate this now, these two things, to what we talked about on the other page. And on the other page, what we talked about is that, let me go back over here. We need to check down here at the bottom that the variability of the residuals is the same for all x's, okay? The variability of the residuals is the same for all x's. So this is like a range for all the y values. Each of these are a range for all the y values. These are the little graphs that, like, for this x value, for x equals 3, this is the normal distribution from the other page that's going up and down. So this is actually that normal distribution right above x equals 3. And then when x equals 4, we've got another one. It is up at 17, 18, 19, 20, 21, 22. It's moved up a little bit, and we have a certain range of values. So when we want to show the variability of the residuals is all the same, that means that this 1.3 is the same that it's got kind of the same standard deviation all the time. So now we're going to look at this. If x is the middle 95% of the observed y values, what x values should they be between? So I'm going to start the same way. So y is approximately normal with a mean of 2 plus 5x, and my standard deviation is 1.3. So now when x is 5, put 5 in for x, what should the mean be here when x is 5? 27, and 1.3 is my standard deviation. I'm going to draw exactly the same picture, but we actually have a question to answer, an additional question to answer. So the middle number here, this is now 27, 28.3, 29.7, and what, 30.9, and then 25.7, 24.4, and 23.1. So there's my normal distribution when x is 5. And it says, between what two of these values would 95% of the observed y values be? 95% is how many standard deviations of the mean above and below it? 2. So if I go 1, 2 standard deviations above and below the mean, since this is a normal model, that's where 95% of all data values live. Just to review, what percent lives in the first standard deviation? 68%. And what lives in the 3 standard deviations away? 99.7. Close. Yep, 99.7 lives there. So what are the two x values where 95%, between 24.4 and 29.7? So when x equals 5, you would expect 95% of the y values to fall within that range, from there to there. This interval is called a prediction interval. I'm going to write it down here, but it goes in that blank. Prediction interval. I'm predicting what x values, or sorry, this is the range of the y values. I'm sorry. Those should be y values, not x values. The range of the y values, because this was the y. Okay, so this is a prediction interval. When x is 5, I expect the y values that I get from that to be between 24.4 and 29.7. If we're to use sample data to estimate the regression line, the prediction interval calculations are more complicated since there is additional variability due to the estimation. So you'd be happy to know you'll never have to calculate a prediction interval. Okay, but you need to know what it is. A prediction interval is the range for predicted y values based on one x value. For the what? Oh, sorry, we forgot to finish this one. So I found that, so now I want to do, let's back up to here. So we want to know what is the probability that y is greater than 23.2. Thank you, Carly, for asking me to finish that. So probability, since this is normal, Carly said, don't we just do NCDF? Yes, we do. So 23.2 is actually right about there, and I want to know what's the probability that it's greater than that. So that's where I can just do NCDF, and then I type in my lower bound. What's my lower bound? 23.2. My upper bound is infinity, so some 9s, and then my mean is 22, and my standard deviation is 1.3. And then if you do that, I believe you get 1.1780. So the probability that you get something greater than 23.2 is about 18%. Now, the purpose this serves is to refresh your memory a little on normal distributions, too. All right, so we did a problem on milk and mucus where we had, the X's were the glasses of milk. So we had 3 people that had 0 and 3 that had 1. And then Y was the amount of mucus. So if we're looking at, I'm just trying to describe a little bit of what we've talked about up here. So the example below is for the milk and mucus data. The solid line in the middle is the sample regression line. So this is y hat equals a plus bx. So that's our regression line that we got from here. The curves on the outside, these are the outside curves, mark the prediction intervals for individual values. So like we found here, the prediction interval, 95%. So when x is 0, when they had no glasses of milk, the amount of mucus should have ranged from here to here. Did it? Yeah, it was actually much closer than that. And when you had 1 glass of milk, it should have ranged from here to here. Now notice it's not just 2 completely horizontal lines. I mean, they do kind of increase, and there's a slight curve to them, but they do go up kind of about like this. It's kind of like you just giving yourself a range. This is where my y value should be. My y value should be within this strip. That's kind of how you check a condition too. If they're within this strip, then you're probably okay. All right, so the curves on the inside, so these are the curves on the inside. They mark the confidence intervals for the mean value of y at each value of x. So this, from here to here, is the confidence interval. I am 95% confident that this interval captures the true y values for this value of x. So right here, I am 95% confident that this interval captures the true y value, true mean y values for this value of x. So that's different. Actually, it gives you a little less room for a confidence interval. So, again, the curves on the inside mark the confidence intervals for the mean value of y at each value of x. All right. On to the next page. And now we just have what the conditions are. So, checking the conditions for inference, there are 4 conditions. The first one are the treatments assigned at random. That's if you have an experiment. And if you have an observational study, is it a random sample? The reason we ask about the treatments here is we're referring to the mucus data, which was an experiment. So, we just have to check to see it was assigned at random. The linear model is appropriate, and the way you check that is with a residual plot. So, let's review how we get the residual plot.